Ancient Egypt had no clocks, no satellites, and no math beyond basic arithmetic. Yet their calendar was accurate enough to predict the Nile's flood almost every year for 3,000 years. Google, with access to atomic clocks and global satellite networks, still has to manually patch its calendar system almost every year. That shouldn't make sense. More technology should mean less maintenance. But it doesn't, and understanding why reveals something almost nobody talks about when they explain how time actually gets organized. Here's something most people never stop to think about. A day isn't really 24 hours. A year isn't really 365 days. Those are approximations. The Earth takes about 365 and a quarter days to circle the Sun, not a clean number, not something that divides evenly into months or weeks. Nature simply doesn't hand us round numbers. That leftover fraction might sound like a rounding error. It isn't. Left alone, it adds up. Ignore it for a few centuries, and the calendar quietly drifts away from the actual seasons. Planting months slide into what used to be winter. Religious festivals stop lining up with the sky events they were built around. For most of human history, this wasn't just an inconvenience. It was a survival problem. Farmers needed to know when floods or frosts were coming. Rulers needed a reliable way to collect taxes and organize labor. Priesthoods needed to fix the dates of religious observances years in advance. And the challenge was never really the math. Working out the length of a year is difficult, but solvable. The real challenge was getting an entire population, thousands, then millions, then billions of people, to accept the same correction on the same day at the same time. That problem is still with us. We've just outsourced it to something that runs quietly in the background of every phone we own. Long before satellites or atomic clocks, ancient civilizations had already figured out that time needed managing, not just measuring. And they built very different systems to do it. Start with Egypt. The Egyptian civil calendar ran on a simple structure, 12 months of 30 days each, plus 5 extra days added at the end of the year. That gives 365 days total, clean, predictable, easy to use for record-keeping and taxation. It was also closely tied to the Nile. Egyptian priests linked the calendar to the flooding of the river, which they connected to the yearly reappearance of the star Sirius in the dawn sky. For a civilization that depended on the Nile's flood to grow food, predicting that event wasn't a luxury. It was survival, but there was a problem baked into the design. 365 days is close to a solar year, but not exact. It's missing that extra quarter day. With no leap year correction, the Egyptian calendar slowly drifted against the actual seasons over the centuries. The math was simple. The long-term accuracy wasn't. Babylon took a different approach. Instead of building a calendar around the sun, Babylonian time-keeping followed the moon. Lunar months were easy for anyone to observe just by looking at the sky. But 12 lunar months don't add up to a full solar year either. They fall short by about 11 days. So Babylonian authorities periodically inserted an extra month into the calendar, called an intercalary month, to pull the calendar back in line with the seasons. This wasn't automatic. It was a judgment call made by royal or priestly authority based on observation and tradition. Then came Rome. By the 1st century BCE, the Roman calendar had drifted badly out of sync with the actual seasons, partly because the officials responsible for inserting corrective days had, at times, manipulated the calendar for political reasons. Julius Caesar's solution, in 46 BCE, was blunt. He added extra days to that single year to reset it entirely. A year that ran significantly longer than normal, sometimes referred to as the Year of Confusion. Going forward, he established a fixed rule, a leap day added every 4 years. It wasn't a perfect fix. It was close enough to work for over 1,600 years. Notice what all 3 systems have in common. Each one solved the technical problem of tracking time reasonably well. But each also depended on something else entirely, a single trusted, or feared, authority with the power to declare a correction and make an entire population follow it. A pharaoh's priesthood, a Babylonian king, a Roman dictator. The calendar wasn't just an astronomical tool. It was a demonstration of who held the power to define time itself. That raises an obvious question for the world we live in now. There is no single emperor issuing decrees to the entire planet. No pope whose word automatically resets everyone's calendar. So how does a system with 8 billion users, no throne, and no priesthood manage to do the same job? Google Calendar launched in beta on April 13, 2006, built by a small team inside Google as an internal project before it became a public tool. On the surface, it looks simple, a digital version of a paper planner. Underneath, it's solving the exact same problem Egypt, Babylon, and Rome once solved, just at a scale none of them could have imagined. Here's the challenge. Billions of devices, spread across every time zone on Earth, all need to agree on what time it is, right now, without a king or a priesthood to enforce it. So who, or what, plays that role today? The answer is that the authority didn't disappear. It moved, and it split into pieces. First, there's the time zone problem. Every device that shows you the correct local time is quietly pulling from a shared reference called the IANA time zone database, a continuously maintained, publicly available record of every time zone on Earth, including the political decisions that change them, like a country shifting its daylight-saving rules. When a government changes its time zone policy, this database gets updated, and that update quietly spreads to essentially every computer and phone on the planet. Second, there's the precision problem. Devices don't just guess what time it is. They synchronize, often using a system called network time protocol, which pulls extremely accurate time signals that ultimately trace back to atomic clocks. This is how a laptop in Tokyo and a server in California can agree on the time down to a fraction of a second. Third, and strangest of all, there's the leap second. Earth's rotation isn't perfectly steady. It varies slightly over time. So global timekeeping authorities, including the International Earth Rotation and Reference System Service, occasionally add a single extra second to global clocks to keep our human timekeeping system aligned with the planet's actual rotation. This has happened periodically since the 1970s. Most people never notice. Behind the scenes, it's a real, deliberate correction, conceptually not that different from Julius Caesar stretching a single year to fix accumulated drift. So the modern system still has the same basic ingredients as the ancient ones. There's still a reference point everyone has to agree on. There's still a correction that occasionally has to be made. And there's still an authority, now made up of scientific institutions and engineering standards bodies instead of emperors, that has the power to declare that correction. What's changed isn't the existence of that authority. It's how invisible it's become and how fast its decisions now travel. Strip away the priests, the satellites, and the software, and both systems are doing the exact same four things. First, there's a natural cycle that refuses to divide evenly. Earth's rotation, Earth's orbit. Second, there's a design rule that approximates that cycle well enough to be useful. A leap day, an intercalary month, a leap second. Third, there's a trusted authority with the power to declare when a correction is needed. And fourth, there's a way to distribute that correction so that everyone adopts it at roughly the same time. Change the outer layer, stone tablets versus software updates, and the underlying machine is identical. Egypt, Babylon, Rome, and Google Calendar are four different versions of the same four-part system. That's where the similarities run deep. In every case, tracking time was never the real bottleneck. Deciding and enforcing was. Even now, with no single ruler in charge, there's still a root authority somewhere in the chain. The International Earth Rotation and Reference System Service decides when a leap second is needed, in the same basic role a Babylonian priesthood once filled by deciding when to add an extra month. And in every case, the calendar was never really about the calendar. It was infrastructure serving something bigger, floods and harvests in Egypt, religious observance in Rome, and global commerce, aviation, and finance today. Nobody builds a time-tracking system for its own sake. They build it because something larger depends on everyone being synchronized. But the differences are just as real, and they matter more than they first appear. The biggest one is the cost of getting everyone to agree. When Pope Gregory XIII corrected the calendar in 1582, removing 10 days so that October 4th was immediately followed by October 15th, the change didn't spread evenly. Catholic countries adopted it quickly. Protestant and Orthodox countries resisted it for religious and political reasons, some for centuries. Britain didn't adopt it until 1752. Greece didn't adopt it for civil use until 1923. A single correction took over 300 years to fully propagate across the globe. Compare that to a modern time zone update or a leap-second adjustment, which can reach billions of devices within days, sometimes hours, through a single software push. The math hasn't gotten dramatically harder to solve. What's collapsed is the time it takes to get everyone synchronized once the decision is made. There's also a visibility difference worth noting. Ancient calendar reforms were public events, sometimes contested, sometimes resisted outright, because they touched religion, politics, and daily life all at once. Modern time corrections are almost invisible by design. Most people have never heard of a leap second, and most never will, because the system is built to make the correction disappear before anyone has to think about it. Underneath all of that is a pattern that connects every version of this problem, ancient or modern. The hard part was never really astronomy. Egyptian priests, Babylonian officials, and Roman calendar keepers all understood, reasonably early, that a year wasn't a clean number of days. The genuinely difficult problem was always coordination, getting a large, spread-out group of people, or in our case, machines, to accept the same correction at the same time, without the whole system falling out of sync. Every civilization that has ever tracked time has really been running a trust and coordination system, dressed up in the language of astronomy, which is why this pattern doesn't stay confined to calendars. Once you see it clearly, it shows up anywhere a large group of independent people or systems needs to act as one. A shared currency only works because a central authority backs its value and everyone agrees to treat it as real. A shared language only works because enough people agree on the same meanings for the same words. Internet protocols only work because engineering bodies agree on shared standards that every device follows without being forced to. In every case, the pattern repeats: a shared reference point, an authority capable of issuing a correction, and a fast, low-friction way of getting everyone to adopt it together. The calendar just happens to be the oldest and clearest example of a problem that never really went away. It only changed its costume. So the next time your phone quietly adjusts for a time zone, or a meeting invite just works across 3 continents without anyone thinking twice, remember that you're looking at the modern face of a problem that once took popes, emperors, and priesthoods to solve. Which makes me curious. Where else in your life do you think this same pattern is hiding? A system that looks purely technical, but is actually held together by trust and agreement. Drop your answer below. I'll pin the best one.